Functional groups are specific groups of atoms within molecules that determine the chemical reactivity and properties of those molecules. They play a crucial role in the structure and function of organic compounds. Now, why are they important in food chemistry? Well, functional groups affect taste, smell, solubility, and reactivity, which are essential for food preservation, flavoring, and nutritional value. Let's take a quick look at some common functional groups: alcohols, aldehydes, ketones, carboxylic acids, esters, and amines. Alcohols contain a hydroxyl group, which is O, attached to a carbon atom. A common example is ethanol, with the chemical formula C2H5OH. Its structure looks like this: HHH, C, C, OHH. Alcohols are polar due to the hydroxyl group, making them soluble in water. They are used in beverages as a solvent and in food preservation. You can find alcohols in beverages like beer, wine, and spirits. Ethanol is also present in fermented foods like kombucha. When it comes to reactions, ethanol can be oxidized to form acetic acid. The reaction is C2H5OH with an oxidizing agent forming CH3CoO. Aldehydes have a carbonyl group, which is C equals sign O, at the end of a carbon chain. A well-known example is formaldehyde with the chemical formula HCHO. Its structure is OHCH. Aldehydes typically have strong odors, which makes them important in flavor and aroma. They are present in various fruits and vegetables. In food, you can find aldehydes in fruits like apples and in vanilla extract. Vanillin, a flavor compound in vanilla, is an aldehyde. Aldehydes can be reduced to form alcohols. The reaction is RCHO plus H2, forming RCH2OH. Ketones also contain a carbonyl group, but it is located between two carbon atoms. Acetone, with the chemical formula C3H6O, is a common example. Although ketones are not commonly found in food, small amounts can be present in baked goods and dairy products during fermentation or spoilage processes. Additionally, certain flavors derived from ketones are used in flavorings. The structure of acetone is OH3C, C, CH3. Ketones are less pungent than aldehydes and are commonly used as solvents and in flavorings. They are found in some baked goods and dairy products. Unlike aldehydes, ketones are generally more stable and do not oxidize easily. 5. Carboxylic acids. Carboxylic acids contain a carboxyl group, which is denoted as CoO, and are known for their acidic properties. A common example is acetic acid, with the chemical formula C2H4O2. You can find acetic acid in vinegar, which is primarily used in salad dressings, marinades, and pickling. Now, let's talk about the structure. The structure of acetic acid looks like this: an oxygen double bonded to a carbon, which is also bonded to a hydroxyl group and a hydrogen atom. Carboxylic acids have some interesting properties. They have a sour taste and are responsible for the acidity in foods like vinegar. They are also soluble in water due to hydrogen bonding. When it comes to reactions, carboxylic acids can undergo neutralization. They react with bases to form salts. For instance, acetic acid reacts with sodium hydroxide to produce sodium acetate and water. The reaction is as follows. 6. Esters. Esters are formed from the reaction between carboxylic acids and alcohols, and they are characterized by the CoO group. A well-known example is ethyl acetate with the chemical formula C4H8O2. Esters are responsible for the fruity aroma in products like strawberries and bananas. Ethyl acetate is often used in artificial flavorings. The structure of ethyl acetate looks like this: an oxygen double bonded to a carbon, which is also bonded to an oxygen that is connected to an ethyl group. Esters often have fruity odors and are commonly used in flavorings and fragrances. They are less polar than acids and alcohols, which affects their solubility. In terms of reactions, esters can undergo hydrolysis. This means that esters can be broken down into acids and alcohols in the presence of water. The reaction is as follows. 7. Amines. Amines contain a nitrogen atom bonded to carbon atoms. A simple example is methylamine with the chemical formula CH3NH2. Amines are present in fish and seafood, contributing to their characteristic flavors. They are also found in amino acids, which are the building blocks of proteins in foods like meat, dairy, and legumes. The structure of methylamine is a nitrogen atom bonded to a carbon, which is also bonded to 3 hydrogen atoms. Amines have some distinct properties. They are basic in nature and can have fishy odors. They are important in the structure of amino acids and proteins. When it comes to reactions, amines can react with carboxylic acids to form amides. The reaction is as follows. In this lecture, we explored various functional groups present in food compounds and their significance. Each functional group, alcohols, aldehydes, ketones, carboxylic acids, esters, and amines, was examined for its structure, properties, and examples relevant to everyday food items. Alcohols, like ethanol, contribute to flavor and act as preservatives. Aldehydes, such as formaldehyde, influence aroma and taste in foods. Ketones, like acetone, are important in flavoring and as solvents. Carboxylic acids, such as acetic acid, are responsible for sour tastes and food preservation. Esters, like ethyl acetate, provide fruity flavors in many food products. Amines, such as methylamine, play a key role in the structure of proteins. To summarize, here are some examples. Alcohols, ethanol found in beer, wine, and kombucha. Aldehydes, vanillin, an aldehyde found in vanilla extract and apples. Ketones, acetone found in baked goods and dairy products. Carboxylic acids, acetic acid found in vinegar, used in dressings and pickles. Esters, ethyl acetate found in strawberries and artificial flavorings. Amines, methylamine found in fish, seafood, and proteins. Understanding these functional groups helps in comprehending the chemistry behind food flavors, preservation methods, and nutritional values, laying a solid foundation for further studies in food technology.